All right. Hey, everyone. Welcome to day 19 for Math 133. So I had to switch a few things around. We were going to cover the Chapter 10 project today, but I moved it to Wednesday because uh, we haven't gone over the Chapter 10 review, and there's still some Chapter 10 lecture notes. It's not a particular section, just this flow chart, but I figured we should wrap up material for Chapter 10. And then on Wednesday, we'll do the Chapter 10 review. We'll do the Chapter 10 project. So that means today, instead, we are going to cover the cumulative review number 6, which is covering chapters 1 through 9. So all material that we've already done. So sorry about the switch, but it looks like nobody's worked on those yet, so it shouldn't mess anything up. Um, anyway, the chapter, so the chapter 1 through 9, the cumulative review worksheet number 6, you're going to find that on page 554 in your course pack. So here it is, page 554. Um, and just like most of our worksheets, we'll go over some hints for you, and then we'll work on it together, make sure everybody gets all the right answers, and then get it turned in. So in Canvas, there is a little bit of StatCrunch stuff to do as well. So if you click on StatCrunch, sorry, not if you click on StatCrunch, if you click on Canvas and you click on the cumulative review worksheet here in Canvas, it says the data sets are available at this link. So if we click on that, that'll bring us to the data set. So you don't have to type anything in. Not that it's really that long to type in, but and then once StatCrunch loads, make sure you sign in or register. So there we go. So like I said, it's not that big. Uh, it's only, 15 or so numbers. So okay, so but I'm gonna jump back over to the worksheet for now. And start with my name. John Perkins. Okay. Oh, I guess we are gonna start the StackCrunch file for this worksheet available at this. Oh, okay, so we already did that. So um okay, cool. So uh this scatter plot shows the relationship between US state's average per person income and its food insecurity rate. So they've done a linear regression for us, and they've already done the StatCrunch work here. Okay. Um, so we don't have to do anything in StatCrunch for this part. It's just kind of reading it off. Okay. So make sure you pay attention to your units. Okay. So the income is in thousands of dollars. Uh, and then the units over here is going to be percent. Okay. So all of this linear regression stuff, we talked about this in chapter 4, okay, which you can find information on page 233. Okay. So what is the linear regression equation? So you can write it either way. You can write mx plus b, but StatCrunch always gives it to you the other order, right? StatCrunch always gives it to you as uh, a number plus or minus a number times your x. Okay. They always give it to you in that order. I'm fine either way that you write it. Okay. And this is our y hat, right? The linear regression is always an estimate, right? The actual data are the points on here, the dots. And some of the dots are on the line or close to the line, right? But the points that are actually on the line are estimates. So that's why we use the hat. Okay. What is the slope and interpret the slope, right? There's a script for the slope, okay? Right. So again, page 233. Explain why your y-intercept does not make sense. There's no script for that. You just use logic. Okay. Mm. All right. Page 555. 555. All right, so this one's in StatCrunch. Following probability distribution. It's based on research of a random group of US adults. Random variable X equals number of days they would wait to seek medical treatment if they were suffering pain that interfered with their ability to work. Okay. So, um, explain why this is a valid probability model. There's two parts to this. Okay. Page 132. So, explain both. Okay. Um, all right. That's no problem. All right. So, we haven't talked about disjoint and not disjoint in a while. Disjoint means they cannot both happen at the same time. Okay. So, to calculate part B, we must assume that the value for number of days are what? So, can 1 day and 2 days both happen at the same time? Okay, so you have to think about that. Not disjoint means they can happen same time. Okay, and not disjoint is the one that takes a little more work, right? When it's not disjoint, you have to subtract the overlap. Okay, with disjoint, you just add them up. Okay, there's no overlap, so you don't. So subtracting zero doesn't do anything, right? So, okay, this is the big one right here. Find the mean of the probability distribution, find the standard deviation of the probability distribution. So for both of these on page 232, there were three methods on how to find a mean and a standard deviation, okay, in StatCrunch. So over here, I've got my StatCrunch open. Here's my number of days. Here's my probabilities, right? So if I was calculating a mean and standard deviation, it depends on what I have. If I have the raw data, so for example, this right here, this column, MPGE, that's the raw data, okay? So that would be method one, okay? Method two is if I have a frequency distribution. That was stuff that we talked about in chapter two, right? Relative frequency, cumulative frequency, things like that, okay? And you need midpoints for your classes for that. And that was method two, okay? Method three is if you have a probability distribution, and that is what we have here. We have our classes. Okay, these they don't look like classes, but like you can think of this as 0 to 0.9, 1 to 1.9, right? So you have your groups, your bins, okay? But instead of having frequencies tied to those, you have probabilities, okay? In that case, we're going to be doing method three. Okay, so that's this page 232, method three. Okay. And then to interpret that on page 231, there was a give or take script. Okay. That is what we use when we're talking about mean and standard deviation. Okay. All right. Page 556. Mhm. Um, so for this one, um, check your notes uh, on page 165 to 166, 170, 196, and 197. Um, anyway, so the formula for this random sample is taken, assume the central limit theorem conditions are met. Okay. Compute the standard error. So there's a formula for standard error on page 166. Okay. Um, a research center survey of 1,895 internet users found that this many agreed that online dating is a good way to meet people. Describe the population for this poll. So this is all da 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 da. All something. Okay. Based on these data, compute the point estimate for the proportion who agree. Okay. So point estimate for a confidence interval was if you have your lower plus your upper divided by 2. Okay. That's not what we're doing here. Okay. So we don't need this. Okay. Because we don't have a confidence interval. Okay. We just have the n, which is the sample size. We have the x, which is the number of successes. Okay. So you can find page 237. That's right. 237. Okay. And then page 189 as well. Okay. So we need to do a proportion, which is p hat, which is x over n. Okay. And that's just going to give you your point estimate. Okay. Um, Pew Research Station wants to replicate the survey, but needs to figure out how many people they must survey. Include the point estimate as a prior estimate. Okay. Calculate the minimum sample required. So minimum sample size. Okay. There was a formula. Okay. Which was n equals stuff. Okay. Substitution. Okay, so you're going to plug in the numbers in the right spot, and then you get a result. Okay. Remember, when you're calculating a sample size, we always round up. Okay. So there's a formula, page 239. Okay. If this poll was conducted through a Facebook only poll, the results are unreliable due to which? Um, so we talked about these in chapter 1. Okay. Page 24. Okay. So response bias is that's where uh, questions the interviewer answers. Okay. Non-response bias is that's where people don't fill out the survey. Okay. And then sampling bias, that's where the sample does not represent the population. Okay, so which one is happening here? Okay. All right, page 557, and then we'll work on the worksheet. Okay. Um, find the critical values for 88.5% confidence interval for P. Okay. So the critical values, those are Z alpha 2. Okay. So you can find that on page 236 at the top. Okay. And make sure you shade in the graph, and it's going to be symmetric, right? When we're talking about confidence intervals, we're always doing symmetric. Okay. All right. 2014, there were roughly 500,000 electric vehicles on the road. Da, 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 da. Verified the conditions are met in order to construct a confidence interval. So we need to make sure it's random, right? And this is going to be this, same steps as if we were checking to make sure the central limit theorem applies, right? Central limit theorem it's central. It's important, okay? It allows us to build confidence intervals. It allows us to do hypothesis testing. And so that's why, it's always we're checking the same things. Okay. Okay. If it if you can, if all of these are yeses, if all three are yes, then that means your central limit theorem is good. That means you can build a confidence interval. So that means you'll need a formula for it, right? And that's going to have some plus or minus on it. And then when you calculate the result, you can either do it in Desmos or you can do it in StatCrunch. Either one's fine, right? Page 237 uh, at the bottom. Okay. All right. All right, cool. So now that we've gone over that, I'll stop the recording and we'll go back through and we'll answer the questions, okay?